Hello there. Today we'll be doing number 57 of Neetcode150, find the duplicate number. This is a very difficult problem if you have never seen it before. And even if you've seen it, you might have gone to how to solve it. In this particular problem, we are trying to find a duplicate number in a particular array. And a simple way to do it is to use a set, but we cannot do that because we cannot use, we must use constant space, so we cannot create anything new. So we must be using the array. A simple trick would be maybe we can add up all the numbers and because there's maybe one duplicate, we could get that duplicate number out, but we cannot do that in this situation because there are multiple duplicate items after it compared 2 or more times. So we cannot use extra space, and we cannot find it by adding up using the sum trick. That means the answer is in the array by a process of elimination, and the solution is to use array like linked list, because the item that we are referring to is between 1 and n, which is like we can see the index, we can see the item and the array be used as an index because it's pointing to another item in the array that can be repeated. And because there are multiple pointers to a single integer, that is our particular output, because that's where the cycle begins. So to get the number, we can use a slow and fast pointer to detect the cycle. After we detect the cycle, we can move from 0 and to the point of detection to where the cycle begins by moving from the index 0 and the point of detection one move at a time to get to the solution. The reason is Floyd's algo, which is in extensive detail in Neetcode's video. But basically, we're traveling p plus 2c minus x to meet up with slow, which is traveling p plus c minus x. And because fast is 2 times of slow, so we multiply 2 times p plus c minus x, and we do that equation. We find out that p is actually equal to x, which is the position from distance before we got to the circle from start, and position where we met fast until the position in the circle to start. So let me just bring up his video and his diagram here. As you can see, it has this the cycle minus the x. If we set x to the distance between where we found it, and the p to the distance between the start and the end. Why can we set all these variables? This is the whole cycle, and cycle minus the x is why is this possible? Because we just make these identifications inside the particular linked list, and like, who comes up with this stuff? Well, not me, of course. Floyd did. So what Floyd did was basically he found the detection point, and then he measured the distance between the cycle and the p, and then he subtracted the x out, and he subtracted the p, and they did an equation, and he found p equals x, which is pretty awesome. Really great explanation. I recommend you watch the video. Anyways, so basically with that, we just basically write some code to get the slow and fast pointer, get the position where slow meets fast. And then we set the slow to starting point, and we make sure they meet up. And how are you going to come up with this during an interview? I don't think anyone would be able to come up with this during an interview if you have never seen this before, because Floyd's algorithm, I don't know how often we use Floyd's algorithm for anything. Yeah, just not happening. Creating these variables in the linked list, like, come on, really? Yeah. Anyways, but if you do see this problem, I think you will you will understand. But what is something interesting that we learned other than Floyd's algorithm and is how to use an array like a linked list. So let's check it out. So slow equals to fast equals 0. So we set that to the 0th index. So while true, we can move slow equals nums of slow, and we can move fast equals to nums of fast. So we move it twice, which is pretty cool. And if slow equals fast, we can break. So we have found the point at which slow equals fast, and we set slow2 equals 0, and while true, we can move slow equals nums slow, and we could move the fast, slow2 equals nums slow2. And if slow equals slow2, return slow. And that's it. That's all the code we need to run. Let's run the code and submit. Perfect. And that's how we solve find duplicate. Excellent problem. Well, thank you very much. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below, and I will see you in the next one. Thank you very much, and see you in the